A penny is dropped off the Empire State Building, which is 1,200 feet tall. If the penny's pathway can be modeled by the equation h of t equals negative 16t squared plus 1,250, how long would it take the penny to strike a 6-foot tall person? What do I do here? What does the 6 represent? The height. So Kayla, what do I do? Or Dylan? Luke?
Put 6 in for h.
Exactly. So if we were to put 6 in, we get 6 equals negative 16t squared plus 1,250. Notice there's no middle terms. What would be an easy way to solve this one? Square root method, absolutely. So if they don't give you a middle term, which means there is no initial velocity, they just dropped it, then all we have to do is use the square root method by subtracting 1,250. What is 6 minus 1,250?
1,044.
Very good. What would my next step be? Divide by negative 16. What is negative 1,244 divided by negative 16? And since we're dealing with time, go ahead and give me the decimal. And actually it'd be positive, but the number was right. So we know 77.75 is equal to t squared. My last step. Square root it. What's the square root of 77.75?
8.816.
We don't care about the negative root of that because we're dealing with time. So it'd be positive 8.81 seconds. That's how long it takes to hit that person. 8 seconds. Well, they're 1,250 feet in the air, so kind of makes sense. Any questions on that one before we go to number 5? All right, number 5.
Does that mean you'd fall in 8 seconds if you're that high?
No. You're coming up the terminal velocity.
Yeah, everything falls at the same rate. Because notice it's not asking for the weight of the penny. It's not a factor. It all falls at the same rate.
So you'd have, like, if you had a parachute, you'd have 8 seconds to hold the parachute thing where you slide.
That would be at 6 feet, so you'd have like, what, maybe 9 seconds? I don't want to find that. Sounds morbid. But yes.
And how do skydivers do it? How fast do they fall down to the ground without
I think they probably calculate that how many seconds they would have to pull the. But they have a lot more time though. They're starting way higher than 1,250. We could look that up. We could look at the math of parachutes.
I would splatter on the ground.
All right, number 5. Some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation for this object's height h at time t seconds after launch is h of t equals negative 16t squared plus 80t. Find the domain of the function. What was the domain values? What did you say?
The domain.
The domain.
It was something just less than x.
It's the x values, right? Very good. The x values are, in this case, it's the time. It's the domain. So our formula is negative 16t squared plus 80t. They want to know how long it takes to get back down to the ground. So what do I set it equal to? 0. Very good. Negative 16t squared plus 80t equals 0. How am I going to figure out my domain? What do I do to solve this quadratic? What'd you say? Yeah, how do I get the t by itself when it looks like this? We don't have a c term.
Okay, you're going to pull it out.
Yeah, we're going to find the greatest common factor. Very good. I think both of you said it. What is the GCF of negative 16t and 80t? More than 4, that's a common factor. More than that?
More than 8? 16.
16, there we go. So we can take a negative 16t out. And what do I have left?
T.
I took a negative out, so it'd be minus. What's 80 divided by 16? 5, very good. Remember, when your A term is negative, you always take a negative out. Alright, so from this one, what would t equal? From the negative 16t equals 0, what does t equal? 0, good. And then from the t minus 5? 5, good. So t is our maximum. What would our minimum be? Dealing with time. 0, very good. So it's going to be 0 is less than or equal to, I'll put t, but you could put x. And then 5 is the max. Because it's not going to go below the ground in theory. Alright, let's do number 6. The Apollo's chariot, a roller coaster at Busch Gardens, moves at 101 feet per second. The equation of the ride can be represented by the equation h of t equals negative 16t squared plus 101t plus 10. What is the maximum height reached by this ride? How do I find maximum height? Vertex formula, very good. So we're going to do t equals, what is our b value in this equation? Over 2 times negative 16. Plug it in your calculator, so tell me what negative 101 divided by 2 times negative 16 is. That's fine. 3.156 seconds. So that gives us the peak, the seconds. How do I find the max height then? Very good. Plug it in. We have h of 3.156. That's going to equal negative 16 times 3.156 squared plus 101 times 3.156 plus 10. Once you calculate it, tell me what we get for our max height.
169.4.
Perfect. 0.4, you said?
Yeah, because it's 3 seconds ago. Turned around.
What's our Ethan?
The exact same thing and you got a different number.
Probably did.
Did you square the 3.156?
Yeah.
Did you add the 10?
Yeah.
I don't remember. I can come look at it if you want.
I put the exact same thing. Oh.
Alright, number 7 is another maximum height, but it asks, would Eva reach the height of 14 feet? We have time. Let's do one more and then I'm going to stop. Are you good, Ethan? Are you good? Eva is jumping on a trampoline. Her height h at time t can be modeled by that equation. Would Eva reach a height of 14 feet? So how do I determine whether or not she'll reach a height of 14 feet?
You gotta find the maximum.
Gotta find the maximum. Very good. How do we find the maximum? Everybody knows now? The vertex. Very good. So we're going to do t equals negative 20 divided by 2 times negative 16. And what will I get there for the time it takes to reach our maximum?
0.625.
Very good. Once you find the time it takes to reach the maximum, what do? Plug it in. We have h of 0.625 would equal negative 16 times 0.625 squared plus 20 times 0.625 plus 6. And tell me what you get for your maximum height.
4.25.
Perfect. What's wrong?
Put the exact same thing in my calculator and it doesn't, I get a different number.
I thought you fixed it. You didn't find the reason before. Alright, let me answer this one and then I'll come help you. You got it?
Yeah.
Alright, so would she ever reach 14 feet? No. Her max height was 12.25. Alright, I'm going to stop.